Good afternoon, students. It is nice to see you all again. It's Mrs. Cinti, and I am going to talk to you today about energy flow in ecosystems. So, with that said, let us move right along. Energy flow in ecosystems. So, where does energy come from ultimately? I'm going to give you a hint right here. It's shining right through those trees. Sunlight gives our earth energy. So, how do we take that energy and use it? You are right now hopefully staying awake and taking notes right now. So that means that you somehow have energy to be able to do those things. And so when you need energy, do you go outside and stand in the sun and hope and your body converts the sun into energy? No. What you have to do to get energy is to eat, sleep, and eat. Okay, so where does that food get the energy? And this right here is showing you the way that it works. Okay, there are three major energy roles. So three users or users of energy that make an ecosystem. The first one is, I think, one of the most important ones, the producer. Okay, so we have this lovely producer, and what they do is they, as their name would say, produce or make its own food. Okay, so here's a producer, and it produces and makes its own food. We're going to come back to each of these and look at examples, but just to give you an overview. The second type of energy role is a consumer, and this is what we are, okay? We are consumers. We get our food from other organisms, and that means that we get our food from other animals or from other plants, okay? But consumers get their food from other organisms. And then the last role is a decomposer, okay? A decomposer breaks down biotic waste, okay? So dead animals, dead plants, okay? Dead things, okay, and returns the raw materials back to the ecosystem, okay? And the raw materials is something that we're going to talk about coming up soon, and that's why you will take a whole course in chemistry, is the raw materials are the elements and the molecules that need to be returned back to the earth, okay, that so they can then be used again to create they can then be used to create more organisms, okay? They can, all of those things. So absolutely crucial. All the different, we consumers are, I don't know how important we are, but there are definitely all these different roles that are there, okay? Let's erase that and let's move on to the next one. So specifically, let's look at a producer and let's list a couple of these examples. The obvious one would be plants are an example of a producer, okay? This is a huge example of a producer. Another one would be algae. Okay, I don't know if you have a fish tank, but algae grows like crazy in my fish tank. And it grows like crazy in the fish tank, especially if it's exposed to a lot of sun. So that gives a hint of what helps these things grow. Another example is some bacteria is an example of a producer. This is more of an exception. It's kind of cool. I'll go into that in a second. And then there's also that phytoplankton. In the ocean, plankton. I think I spelled that totally wrong, but that also uses energy to produce, uses energy and captures energy from the sun. So the ingredients to make energy that we can use, there are usually three, and of course the bacteria might be an exception, but in general, the ingredients to harness energy is what I'm going to say. Harness energy are the sun, so sunlight, plus carbon dioxide, okay, plus what do we give to plants to help them to grow? A whole bunch of water. Okay, so these are the ingredients in order to produce or to harness, energy. It's not being produced, it's already there, but we just need to harness it and put it into something that will be helpful. And as you are seeing, so here's the sun going into this plant and the chloroplast, we'll talk about this later. This is a process called photosynthesis, okay, but we aren't going into that right now. But energy comes from the sun, carbon dioxide gets mixed in, water gets mixed in, so these are the ingredients, and what comes out is oxygen, thank goodness, because we need that. And sugars. Okay, sugars are basically molecules that have a lot of energy in them, in the bonds there. Okay, so the ingredients to harness energy is sun, but then you also need to mix in carbon dioxide and water. And you get, coming right out of that, you get sugar and oxygen most of the time. Now the bacteria, there is a unique example of bacteria, and I'm forgetting what the name is right now, but that bacteria can produce or can harness energy in a place of no light, and we've just discovered it just in the past few years. It can use the resources that are around it, and it uses some gases to harness that energy to produce those same kind of sugars in order to do that. So I think that's very neat. So our next topic, the next one would be the consumers, okay? So us, okay? There are a number of different types of consumers that are here, and the consumers are as these go, okay? There are herbivores, okay? Herbivores will only eat plants, no exception. Okay, they only eat plants. Okay, good examples of these are deer. Deer is not going to go and eat a mouse. You know, it will really only stick to plant life. Okay. Another example is the panda bear. I like those pandas. I love that bamboo, right? Another example would be something like cows. You know, they are generally not going to eat other animals. Chickens may not actually go under that category. I was just thinking about cows and chickens. But chickens, I have seen and I have heard eat beetles. They like bugs and mosquitoes. You can get some chickens that really like mosquitoes to cut down on your mosquito. So just a little side note. Carnivores, this picture I picked out just because I thought it was so cool, but this is actually showing an example of how this, I think a wolf or a coyote is not acting as a carnivore, but carnivores only eat animals. And there are no exceptions, which is funny. I just somehow spelled eat wrong. Animals. Okay, sometimes we are forcing some of our carnivores because, not really forcing, but we're making it easy for them to get food without having to hunt for food. And so if you had, you know, a bunny over here that you would have to chase for an hour versus the picnic table that was empty, nobody was sitting there with a big watermelon on it, what would you choose, right? It's a lot of energy to hunt. And so some of our carnivores, our keystone carnivores, sometimes are now, they are diverging from their role, and they are eating plants too sometimes, but really not very often, okay? That's not really the definition. So examples of these are like lions. Lions, sharks is another example in the ocean. And then even this zooplankton, and we'll be talking about these a bit in our examples, but zooplankton, oh my gosh, I think ton. Okay, zooplankton is another one example, or zooplankton, some people call it. And then there are the omnivores. We are mostly these, those of us who eat both plants and meat. Omni means all or every. So they aren't exclusive to just one. They eat both meat and are both animals and plants. And I have this bear here because bears, even though I have a very healthy fear of bears, they have, you know, they don't eat humans. They don't attack humans unless provoked. But they really prefer berries. They love berries, except when the salmon are running. So bears really, really like to eat salmon as well. It's very healthy for them, but also all those yummy berries that they can find. Okay, so that's an example of omnivores. And then scavengers. Scavengers are carnivores, kind of. They should be under the carnivores, but they only eat dead organisms, okay? They are carnivores that eat dead organisms. All right, I'm going to go see if I can scavenge any food in the kitchen, meaning I'm going to try to find something that's already prepared for me that will be easy to make, right? So those are examples of consumers. So next. So decomposers are basically known, decomposers are known as our recycling bin, okay? What they do is they take all of the dead, dying, fallen things and they turn it back into what they were originally made out of. All of the elements, basically all of the periodic table, all those elements that are contained in them. So the nitrogen, the oxygen, molecules and atoms, phosphorus, phosphates, all of those things. So these are crucial. Good examples of these are fungi, which are a classification of mushrooms. They are worms. So they're the things that we kind of don't want. Mold, which would also kind of be classified here. Some bacteria are good examples. Some bacteria, all of those sorts of things. So in general, these are crucial. So if they're yucky, some beetles, I saw some examples of beetles. But worms, when you see them, of course you don't want them crawling all over you, but they are absolutely crucial. Because what would we do if there were only producers and consumers? We would be sifting through the debris of fallen trees because they wouldn't be able to break down. So all the trees that fell in that fall would only still be on the ground now. They wouldn't be breaking down. They wouldn't be changing back into soil, right? And we need all these things too. All the dead animals, we would just be walking around among carcasses of animals. We'd have to scoop it up and move it over, right? So decomposers are absolutely crucial. They're the only way for us to get the nutrients back into the soil, so it can be used again, right? So once a log falls, if everything was stuck in all these dead or fallen over things, then there wouldn't be any energy that there would be plenty of energy because the sun is producing the energy, but there wouldn't be all the nutrients, all the elements, the carbon that we need in order to make sure that in order to grow. We wouldn't have the nitrogen. We wouldn't have anything necessary. So all those crucial ingredients would be caught up in all the dead organisms that are floating around. So I like this image very much from your book, actually, because it's talking about, it's asking you to kind of identify and think about clues that would tell you which kind of animal was the one that broke into this campsite. So it's saying you went hiking and some hungry animals turned your campsite underground. Upside down, sorry. There's the example of the bear. Mold could have, rabbit could have, and wolf could have come in and taken over your space. And so the question is, what would have eaten all the chicken out of your salad, right? What animal would only go through and eat the chicken out of there? Would it be the bear? Would it be the mold? Would it be a rabbit? Or would it be a wolf? Okay? I would say a wolf, frankly. Okay? What came along and ate, nibbled through, and I use the word nibble, sorry, but ate some of the tomatoes and lettuce that had fallen on the ground? I would say perhaps a rabbit or a bear. But a bear, probably, they have a pretty big jaw. I would say that they would probably have eaten the whole thing if they had gotten access to this. What went through and ate, ripped open, got into the tent somehow, ripped open the cooler? What could have gotten there, right? What could have gone in there and eaten the beef jerky? Or maybe, I guess it didn't rip open, the tent was left open. These are I wouldn't go hiking with all my food left out in a nature place. Like, this seems like a very irrational adult right here, but whatever. And then there's mold on here. So a nice thing for you to go through when you get a chance. Okay. So let's summarize real quick. Let's summarize real quick. What is the main source of energy for all three energy roles of the producer, consumer, and decomposer? And the answer is the sun. That's really, I should have said just the sun, but that's really where all the energy is coming from. And we just, the producers are the ones that are just somehow harnessing it. Well, not somehow. They are harnessing that sunlight energy and turning it into energy that we can form. So when those plants are there, how does energy move through the ecosystem? So how plants are the ones that have it, where do we get our energy? And then I clicked a little too fast, but as you can see, it is from the eating. Okay, we have to eat. Okay, we don't have to eat meat. We don't have to eat a lot of these things, but as long as we're eating something, we tend to be getting energy. And if you have noticed, the one thing that we pay attention to sometimes when we're shopping is we pay attention to the number of calories that are in food. Calories is really the amount of energy, because we are not concerned that we're not going to get enough energy as humans in general. We don't really worry about the number of calories, or we worry about it for the other side of we don't want to gain too much weight by consuming calories. But if you are an animal that is out there in the wilderness and there's not a lot of food and you're hunting, you are looking for the highest calorie object that you can possibly find. Okay, so we are slightly spoiled in our example. So the way that we follow energy through an ecosystem, or we pay attention to an organism, is we look specifically using a food chain. Okay, so if we're wondering where the energy that was caught up in this corn, right, the leaves on the corn stalk harness the energy and using by photosynthesis, etc., and then it turned it into the sugars that are in this corn right here, and then a mouse came and ate it. And so the energy from this corn went into the mouse, okay? And then this little mouse guy, he ate it, digested it, he got some extra energy because of it, and then look at who ate him. So who got the energy there from the corn, okay? So this is called a food chain. And a food chain is really paying attention to just one set of relationships between these three things. But as we know, so let me just define a food chain. It allows us to follow one organism's effects on one another. Effects on another, let's say. And it is one way that energy moves. Okay, so this is a food chain, okay, just one sequence of movement of them. However, let's look, as you know, more than just one thing eats that piece of corn. More than one thing eats a carrot. And so let's look at the next example of something. So here is another place where you would see a whole bunch of animals interacting. Let me change the color actually, because that's not going to be very helpful. And so here is a producer. This is really the only producer that I'm seeing here on this picture. The duck is not producing energy from the sun. The Arctic tern is not. The loons, no. None of these things can produce energy except for this one in that ocean. Okay, so this is the only thing that is actually harnessing the energy from the sun and turning it into energy that can be used. What happens is, of course, we need to get that energy. Somehow all of these organisms need energy. And so the zooplankton comes along and eats it. Okay, animal plankton or the zooplankton. Okay, this is algae or just phytoplankton. And then these guys need energy. So what they do is they focus on this zooplankton. So they eat that. Okay, and so the energy from here goes into here, goes into here. This guy is like, hey, there's some energy there. So these guys are eaten by the Arctic cod. And so this one gets some energy. And then you have the ring seal, and then you have the polar bear. Okay? However, it's not just the polar bear who eats the ring seal. It's not just the ring seal who eats the Arctic cod. These guys, it's not just the silversides that are eating the zooplankton. Okay? All of these things are interconnected. Okay, this is one food chain. So I just drew one chain, but really the way that organisms interact is it's not like these guys are the only ones that can eat these guys and these guys are, it's not one directional all the time. There is a web that occurs, okay? So a food web, well, let me show you what actually this web looks like, and I think it's really cool once you see the change. This is a food web. Okay, this is the food web. This is a relationship. So these guys are actually eaten by loons, by the Arctic tern, by the sea duck. The sea duck also eats the zooplankton. They also eat some of these worms that are in here. The beluga whale eats starfish. It's actually kind of cool watching them eat starfish. And then the silversides, and then also the Arctic cod. It's amazing. Okay, so this is a web. This actually shows all the interactions that are occurring between these few animals. So most organisms are part of food webs instead of food chains. Well, and food chains, which are involved. Okay, so most organisms are part of numerous. Oops, chains. And so that's just something. And so the food web shows the connection between all of the organisms together. Okay. Now, as far as energy, right? These guys are the ones that harness the energy. But one thing that's important is how much energy is actually being exchanged from this to this to this. Okay, and so that's what our kind of last topic is going to be about today. We use something called a food pyramid to explain how energy is moved from one feeding level to another. Okay, so food pyramids show how and how much, I guess just how much energy moves from one feeding level to another. And what's crucial to understand is that only 10%, and I would really say only, I should have written only first, only 10% is transferred from one level to the next. Sorry, writing all over the poor picture. Okay, because the remaining 90%, the 90% that is not transferred, is lost to heat up the original organism, okay? So here's the producer. The producer holds 100%. They have made all 100% of the energy. When this primary consumer comes and eats some of the energy from this producer, they are only getting 10% of the 100% that is contained within that producer, okay? And so what we do is we move the decimal over between each step. So if we move it over 1, we get that 10%. When we get up here, we're moving the decimal over again, and so we're at 1%. So this one is going to eat this one and this one. So what's interesting is it's not just producer to consumer to decomposer, right? There are lots of people, this eats this, this eats this, this eats this, or this, I'm sorry, this eats this, this eats this. So there's lots of different consumers. So what's interesting about a pyramid is that there are many different levels of feeding that occur. So the top of the pyramid, the final carnivore that's there, has actually, there's actually so few of them that exist because there's so little energy to be had because it's all being lost between the two. Okay, so I don't know how clear I was on that, but let's work through an example, okay? One example to work through right here. So let's say that we start with, how much do I want to start with? Let's say that we start with 25,000 calories of energy that is contained down here in the cattail, in these producers, the coontail, the algae that exist all within this aquatic example, okay? How much energy, once these guys come and eat it, how much energy is going to then be in this area? Okay, so going from here to here, we lose 90%, so we move the decimal over this much, okay? So 2,500, so we're at 2,500 calories now. Okay, that's how much is available to those guys. Then we go up again, energy is being lost as heat energy, and then we have another loss of 90%, so we move up 10% to 50 calories that exists in the green sunfish. Then we move up to largemouth bass. Of the original 25,000 calories available, the largemouth bass is only going to be getting 25 calories. And then this poor great blue heron will only be getting 2.5 calories of energy from the very bottom. Okay, so that's an example of movement between the two. So just some last things to note. the amount of energy originally in the producers will determine how many consumers can be supported in that ecosystem. Okay, so depending on what you start with, how many producers are available within that environment will really determine the rest of the pyramid, what will happen on that pyramid, okay? So we'll work through some examples in class, but thank you for listening and have a great night.